Hello. In physics we use tables and graphs a lot, and in this short video I want to explain how you can use spreadsheets of LibreOffice to make a graph in a very easy way. For instance, I have a spring. I have two springs actually, spring A and spring B. Certain elongation when there's a force applied to the spring, and I want to display that in a graph. The first thing I do is to select the data, including the titles. You will see why that's pretty good. Then I say insert a chart, and then there's different types of charts. And in physics we actually always want to display the measured points, the measured data, so we do xy scatter, and we say finished, and at least we have something. Now the nice thing of LibreOffice, of any spreadsheet program actually, for in Excel it works about the same. The nice thing is that it immediately puts values to the axis, and it labels the springs. Spring A, the blue squares, and spring B, the orange dots. So from the table you can figure out that horizontally the force is displayed on the horizontal axis, and vertically the force. Now we have to make the graph according to the rules of physics, so we have to edit it, and we can insert titles. Insert a title. The title is Force Elongation Diagram, and then there's no subtitle. The x-axis has the force in Newton, and the y-axis has the elongation in centimeters. And we click on that one, then you see the elongation centimeters, the force in Newton, and then, well, it will be nice to have a bit of a grid. Okay, to add more vertical and horizontal lines, I only want to show you the x-axis. So you click the x-axis, format x-axis, and then you can select, for instance, okay, most of the times all is selected automatic. The maximum force is 10 Newton, so why not going down to 10 with this one. The major interval is 2, but let's say you want to have a grid line every 1 Newton, and then the last one also should not of course exceed 1, but you make a major grid of 0.5. You click OK, and then you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then the second point is you want, in most cases, also a trend line. So you click on a series of data. This is spring A. Right click and you insert a trend line. And then you have to know, of course, for spring there's a linear function, so it is linear. And trend line, you can add a name here, so it is line A if you want, but I don't like it because you get too much data in your graph. Or let's just put it like that, line A. And then for spring, of course, you have to force 0, 0, because at no force there's no elongation, so you have to force the line through the origin. And you can show the equation, for instance, and the x variable is x, and the y variable is f, the function of x. So I say okay, it's there. Now you see the equation there for the line. It becomes now a bit too much, but you can of course format a trend line equation. You don't need that many details, so the numbers is now the number is, if you say two decimal places, that is fine. Ok, and now you have the function for line A. For line B you can do the same, and you have to make sure that you intercept in 0, 0. Okay, this is part 1. Now let's say you want to display the frequency of spring A and B in terms of vibration, inserted in the graph as well. It's a bit odd. In terms of physics, I don't see any sense in this, but it's just to explain the making a graph is a double y-axis. So what I do, I start again and I say I want a graph. I click on the graph and I say edit, and I just say, okay, what is the data? What's the data? Sorry, data range. I select this whole field, including the frequency. Okay, and I say okay, yes. And now these yellow and green dots are coming, triangles are coming, but this is very odd. The elongation is here on the right axis, so I want to add a second axis. So I go to the y-axis, and I add I click on the graph with the right button, and I insert another axis, and I want a secondary y-axis. Okay, and then this axis gets here. Now I want, of course, a data range that fits the frequency. So what I do, I format the axis, and I say the numbers, the scale is not from 0 to 12, but the maximum was something like 2.4. So let's put it 3, for instance. And then the major interval should not be automatic, is 0.5, 0.5, and the minor interval is less, like 0.1. Say OK, then you see this interval is there. But still, the graph itself, and sorry, I did not label the axis. Insert axis title, and the secondary axis title, I forgot to edit that one. Format the title is not okay. What is that? Is just a letter type. Wrong. I have to type it. The secondary is frequency in I want to say in hertz, but it is in 1 per second. So that's hertz actually. Enter, and then, oh, sorry, delete, enter, oh, back. I should say it's okay. So frequency here is in. Okay, let's put this block a bit aside. Up. So you see the frequency in 1 per second or hertz. Now I have not connected these data ranges, the green ones, to that vertical axis. So what I do is format data series, and I connect it to the secondary x-axis. And now it makes more sense. For the other one I do the same. Format data series, I connect it to the secondary axis. Ok. And then we are there. Now, of course, this formula is a bit odd there, so you rather pull it to the trend line of the blue spring, and Here's your graph. You can add trend lines for the other ones as well, but I think this is clear. You can just play with the layout and make it bigger or other letter types, but that's not that important. Have fun!